All right, guys, I'm going to work through this number one from our classwork today. And I just want to immediately point out I did make a change. I apologize. There was a typo. That should say minus pi. So if you were doing this kind of independently, you're like, oh my gosh, this isn't working out. I thought I knew it and I didn't. So yeah, typos are just going to be the death of me in this unit. But if you want to pause the video, give it a shot with that new update. It should work out pretty quickly. All right, so we want to graph the related function negative 15 cosine x over 3 minus pi plus 1. Let's go. We're going to take that inside argument, x over 3 minus pi, call that a column title, x over 3 minus pi, and mark those with our landmarks. These are the outputs of that column. So cosine starts at 1, goes to its minimum, ends at its maximum again. Okay, let's do a little side work here. X over 3 minus pi. What would we do to get x by itself? We would add pi and then multiply by 3. So we're going to take this first column values, our inputs, and we're going to add pi to all of them and then multiply by 3. I'm just going to talk these out, so listen up. 0 times pi stays 0. I'm sorry, let me rephrase that. I'm going to add pi and then multiply by 3. So 0 plus pi becomes pi times 3, 3 pi. And by the way, this would make x. Pi over 2 plus pi. Do this really quickly by 2 over 2, and now you have a common denominator. So this would make 3 pi over 2. And now when we multiply that by 3, we get 9 pi over 2. Pi plus pi is 2 pi times 3 is 6 pi. Just bang this out really quickly. 3 pi over 2 plus another pi. Again, 2 over 2. So this is 5 pi over 2. And then times by 3 makes 15 pi over 2. Add pi to 2 pi makes 3 pi times by 3 is 9 pi. And we have our inputs there. See if I can delete some of this really quick. Bear with me. Sayonara. Oops, didn't want to do that. I'll just use the erase tool over here. Goodbye. I said goodbye. Okay. Next, let's focus on what's going outside the function. Times negative 15 plus 1. So we're going to smack this with times negative 15, then add 1. So that becomes negative 15, add 1, negative 14. That stays 0, add 1. That becomes positive 15, add 1. That stays 0, add 1. That becomes negative 15, add 1. There's our outputs. Let's go to the graph. This is 6 pi. Yes, it is. Halfway, divide by 2. Halfway there would be 3 pi over 2. And to remind you, this is what we're skip counting by. This is what we're skip counting by. Meaning, I can go 3 pi over 2, 6 pi over 2, 9 pi over 2, oops, 12 pi over 2. Okay, what is going on? Please stop that. I don't know what the heck just happened, but okay, you win. You win, computer. All right, 12 pi over 2. All right. This line right here would be 15 pi over 2, and so on. You can do this as much as you need to. And just notice that wouldn't simplify, but this would simplify to 3 pi. This would simplify to 6 pi. Let's just kind of continue on just for another second. 21 pi over 2, 24 pi over 2. Skip counting by 3 pi over 2s. This thing has a weird mind of its own. Apologize for all that movement. And it did it again. Okay, really weird. Eraser. And the whole thing just went. Cool. This is wonderful. All right, I hope you got the moral of the story. But this guy right here is 24 pi over 2, which would simplify to 12 pi. So just want to emphasize we're skip counting by 3 pi over 2s. All right. Boom. No, why? Please don't erase the whole graph. I don't really want to lose the whole graph. No. All right, those are going to stay there because this video is going long now. Let's go. Let's plot these points. So at 3 pi, we're going to output -14. Let's see. I'm going to help my brain out a little bit. This is -5, -10, -15. This is +5, +10, +15. So -14, I guess that's like right before -15, right there. 9 pi over 2 is going to output 1, which I guess is just right there. 6 pi is going to output 16. Here's 15, so 16 is going to be a little bit higher. 15 pi over 2 is going to output 1 again. Yep, that makes sense. We're on our way back down. And then lastly, 9 pi right in the middle here is going to output -14. And then we would kind of connect this like that, connect this like that. And just to remind you, what I've just graphed is the cosine. The question asks us to graph secant. So no matter what, if you have a sinusoid and you're trying to graph its reciprocal, the midlines right here, this is the middle of the max and the min, become asymptotes. So right there, we would do these vertical bars. The maximum point right here is going to be a turning point for this branch that's going to open upwards. These two minimums on both ends are going to be turning points for the graph that opens downwards. And there is one cycle of this graph, y equals -15 secant, blah, 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 +1. So just to be emphasized, what I'm really looking for is this, your asymptote, your opening up, your asymptote, and opening down. That and just that is that graph. The stuff in green you can keep on the graph, but just to remind you, it's a guide of to help us graph what I just shown. All right, so hopefully that was helpful. See you later.